Let's begin our exploration here. This frame was captured in real time by Chuck's astrophotography on December 19th using the impressive 24-inch Starfront telescope. At first glance, the image may seem deceptively serene, a compact luminosity enveloped in a smooth halo, not something that draws immediate attention. However, the reality emerges through subtle geometric nuances. The central area remains sharply defined and cohesive, while the surrounding haze expands irregularly in a particular direction, lacking symmetry and not blending with the star trails. The object retains its inherent shape, while the backdrop of perfectly pinpoint stars reassures us that the tracking is flawless. Why is this significant? Because large apertures are unforgiving. A 24-inch system magnifies tracking inaccuracies, atmospheric disturbances, or processing errors. If a feature presents itself with such clarity here, it's undeniably real and intentional. What we are witnessing is evidence of a persistent structure exhibiting a clear directional tendency, something we observed with smaller telescopes previously. Now, this evidence is undeniable, with much greater resolving power. This image serves as our starting point. Let's now advance frame by frame to discover what alterations occur and, importantly, what remains the same. Next, let's examine the subsequent piece of evidence. This image, also taken on December 19th, was courtesy of Ivan Vasquez from Calopa Stars. Captured using a C-Star S50, when compared to the colossal 24-inch telescope we previously viewed, this system is much more modest, aimed at the consumer market. That's where the proof lies. Even with only 2 minutes of exposure, segmented into 10-second intervals, the object does not dissolve into noise or artifacts. Its core remains surprisingly compact, and the surrounding glow, although not spherical, extends unobtrusively yet distinctly in the same direction we noted in the high-resolution data. Notice what we do not observe: blurred stars from poor tracking or the hallmarks of aggressive processing creating shapes. Despite these conditions, the object's elongated internal structure endures. This is a critical point. Smaller telescopes are ruthless in their own right. The sustainability of a feature with limited exposure and modest optics indicates that this isn't something that only appears with extensive processing or large apertures. What we are witnessing is resilient behavior that is independent of the observational tool used. Whether looking through a large telescope or a smaller one, the story remains consistent. Let's move ahead. Now, we turn our attention to this follow-up frame, also from the same observer. This image is comprised of 15 to 16 minutes of data, still captured on the C-Star S50 during the night of December 19th. With a significantly longer exposure time, the object not only brightens but its structure becomes unmistakably apparent. You can visualize the internal region extending in a narrow, elongated shape, with a brighter area at one end and a more diffuse section projecting outward. The surrounding glow doesn't exhibit a round shape but shows a consistent orientation axis. Simultaneously, the background stars remain perfectly circular, lacking any elongation, which eliminates any chance of vibration, improper tracking, or image stacking errors. The value of this frame lies in its temporal consistency: same instrument, same night, prolonged exposure, and consistent orientation. If it were merely an illusion or noise, the extra exposure would diffuse the feature. Instead, it intensifies. This continuity is what continually draws our focus. Let's move on. Now, we leap to Italy. This image is brought to us by Tony Scarrato, captured on December 18th with a 25 cm Newtonian telescope. This observation isn't casual. It is a meticulously stacked series of images with resolution, pixel scale, and field orientation properly documented. First, in the raw wide-field image, observe the slightly trailed background stars, which confirm that the telescope is accurately locked onto the object rather than the movement of the sky. Right at the center, the three-eye atlas maintains its compact shape. Now, compare this to the resampled close-up on the right. The inner coma is no longer circular. This is not an indistinct blur, but rather a specific, measurable direction. The central condensation is well defined, and around it, the outer coma broadens into a greenish envelope stretching thousands of kilometers. What truly matters here isn't just the shape but the intricate structure within. There's a compact central core, an elongated inner area, and a larger asymmetric outer coma hierarchical system. Once again, this elongation perfectly aligns with observations made in smaller instruments across different continents and on various nights. Different telescopes, varying processing methods, yet the directional behavior remains unchanged. This consistency compels us to acknowledge the evidence. Let's proceed. Now, we focus on New Zealand. This image, captured by Brian Dietrich on December 17th with a 203mm Schmidt-Cassegrain, features quick exposures, minimal processing, and precise tracking. Initially, the scene appears understated, a faint object devoid of dramatic flares or an eye-catching tail. Yet, it is in this subtlety that the strength of the evidence resides. The central condensation stays compact, with no blurring or fragmentation, and the surrounding glow isn't chaotic. It leans slightly in a defined direction, Now observe the inset, which is a stretched view of the same data. Nothing was added or altered. Again, the internal structure does not dissolve into noise, it remains intact. The significance of this is enormous. With such delicate objects, processing artifacts usually dominate, leading to wavering edges, shifting centers, and disintegrated shapes. None of this happens here. Instead, the core stays fixed while the surrounding material shows. The same preferential orientation we previously noted from Italy and Hawaii. Another hemisphere, different telescope, another night, yet the behavior remains consistent. At this juncture, the pattern we're witnessing is not a result of a single setup or observer. It emerges from the object itself. Continuing forward, we completely depart from Earth. This image wasn't captured by an amateur telescope or even a terrestrial observatory. It comes from NASA's Europa Clipper probe, employing its ultraviolet spectrograph. Recorded on November 6 from roughly 164 million kilometers away. What you see here is not a standard photograph, but a composite intensity map plotted in ecliptic latitude and longitude, showcasing where ultraviolet emissions are concentrated as the instrument scans the sky. That bright blue area represents 3I Atlas, and it's crucial to note that the emission is not spherical. It lacks symmetry, being elongated along a specific direction within a broader diffuse structure. Even in ultraviolet wavelengths, from interplanetary space, and through an entirely different observation method, the geometry remains. This is paramount because UV instruments aren't influenced by dusttails or the optics of telescopes. They respond to gas excitation and interactions with solar radiation. Therefore, when a directional structure appears in this context, it is not an artifact of the camera, a stacking trick, or contrast manipulation. It is physical. We now see the same alignment in raw optical images, RGB channel separations, long-time series stacks, and even ultraviolet spectroscopy from a probe millions of kilometers away. Different physical contexts, same orientation. This is no longer a coincidence. It is behavior. Whatever is driving this is still active. Thus, we arrive at different nights, using various telescopes across continents. And now, even from a space probe, 3I Atlas continues to display the same characteristics. A compact core and a directional structure that does not fade, randomly rotate, or fragment. This evidence is not the product of a single observer or a solitary filter, nor does it emerge solely after intense processing. Whatever is driving this behavior, it is stable, persistent, and real. For those just beginning to follow the trajectory of 3I Atlas, allow me to summarize why this object is distinct from others. Below are the anomalies categorized by theme, geometric, compositional, and physical, with brief comments on why each item holds significance. Geometric and orbital. First, a retrograde trajectory almost aligned with the ecliptic plane. Probability, approximately 0.2%. Second, the timing of arrival and fine-tuning with specific distances to Mars and Jupiter appears deliberate. Third, predicted perihelion, near Jupiter's Hill radius, indicates an orbital target. Fourth, an extremely columnated sunward antitail, unusual for comets. Fifth, the rotation axis aligns with the Sun's direction within approximately 8, probability 0.05%. Sixth, a periodic jet wobble of 7.74 hours, only comprehensible if the base is within 8 of the pole. Seventh, the appearance of the jet before and after perihelion with improbably geometric coincidence. Compound probability 0.25. Eighth, gravitational deflection at perihelion of 16.4. Exactly double the jet's opening. Remarkable geometric coincidence. Composition and plume. Ninth, a gaseous plume with high nickel content and little iron, an unusual ratio reminiscent of industrial alloys. 10th, the plume contains only approximately 4% water, well below that of familiar comets. 11th, extreme negative polarization with no parallels among known comets. Physical properties. 12th, a nucleus more massive than Oumuamua, and 2, I Borisov but moving faster, strange for an ordinary interstellar iceberg. 13th, brightness and coloration show rapid brightening and blueness compared to the Sun near 14th, jet alignment and columnation describe new anomalies noted by Loeb. 15th, the requirement for thermal isolation for active ice pockets at the poles. Termed the 15th, the need for extreme isolation if the explanation is natural. Question now is no longer about whether the structure exists. It is about why it remains so pristine and why it is appearing so clearly at this moment. Could it be a jet driven by localized activity? A geometric effect we are observing from the perfect angle, or perhaps something regarding interstellar material that behaves differently than anticipated? Share your thoughts in the comments. I read them all. For those wanting timely updates upon the arrival of new images, please like the video, subscribe, and share this with anyone who has been following the 3I Atlas narrative. We are far from finished with this object.